Hello, good morning. So the morning has begun. I will start with some practical and housekeeping information, and if you also have some pressing issues, don't be shy and share it with me. So I was approached by some people who said that they had some problems installing and registering for something. They specifically were talking about Giovanni's workshop, which is tomorrow, which is good. We have still plenty of time. But I guess maybe somebody also had maybe problems with Annemieka's workshop installing something. So the general rule, let's make like this. So every morning, those who had some problems installing or registering something, we meet 30 minutes earlier at 9. Like, I know it's like the latest, but let's do tomorrow. Somebody who has not something installed, we meet at 9. And today I encourage those who had some issues with installing something for Transcribus or for tomorrow's workshops, meet in the break with lecturers and with assistants. So Annemieke is already here, Transcribus workshop, and who is helping assistants Laura and Greta. So if anybody had any problem installing, registering, so in the first break, which is after Daniel's first 90 minutes, so meet with Annemieke, Laura or Greta, just in case you had some problems. Here is also Giovanni, who has 2 workshops on Wednesday and on Friday. So in the break, those who had some problems installing for Giovanni's workshop, meet with Giovanni. And please, who are assistants for Giovanni? Vladislaus and Stavrula, are you? And Laura, are you also? But you are from Friday, right? So please manage somehow, and Giovanni, please delegate for assistants what can be done by assistants so you're not overwhelmed, okay? Besides from that, we have 2 extension cords. Do we still have them, or are they used already? So because some people apparently have computers and wanted to plug into electricity, do we still have those 2 cords? So there are 2 extension cords somewhere in the room, those who are desperate for electricity. Viesters? 1 over there. Okay. What else from practical matters? Some questions or ideas? Okay, if you don't complain, okay, you complain. Okay, so a general announcement about internet connections. So, generally it should be okay. If it is not okay, then I encourage people who have unlimited internet use your own hotspot. It's also regarding Google Colab. Last year we had some problems. We are not sure of the cause of them, but at some point Google crashed and didn't keep on working. And we guess it also might be related to Wi-Fi. So for people who have their own unlimited Wi-Fi, I encourage you to switch to that. For those who cannot do it, please try again that university Wi-Fi. Also for people who have Latvian university, your own access, you don't. Okay, but those who have, please use that so that we have less traffic on the common. If it doesn't solve it, then yeah, please come to me or somebody and we'll try to somehow. Is it not working at all? Oh, it's just disappearing. It's a common issue? Somebody else? Yeah? Okay, I don't know really what to answer, but if somebody smarter knows possible solutions, then please come to me. And if you are stuck, then also please complain so we can really address this. Okay, something else? Annemieke? I'm not sure I got it, but yeah. Did you hear that? Okay, please react on that. I didn't get it, but it's apparently working. Okay, any more practical issues? One more thing. We made a Zoom link in case you want to follow what's being told on your own computer. The Zoom link is in the preparing for workshops file. Laura, in which section is it? In Daniel's workshop, right? So we have screens, but in case you don't see the big screen, so you can also see it on your own. Okay, with that being said, I have the privilege to introduce Daniel, who is a senior lecturer of digital humanities at Linnaeus University, Sweden, who is working with digital tools in language learning and also stylistic research of literary works. And I met Daniel in DHNB conference in Tartu, and I was really intrigued about what Daniel was talking about his teaching practices, and I thought, well, here's a person who could really give a nice introduction into programming for people who have never done any programming at all. Because although it's an introductory topic, I think that's the hardest to do the introduction in programming for people who have never done something like that. So Daniel, please, the floor is yours. Do you need a chair?
No. All right, good morning, everyone. Will you be able to hear me in the back if I speak at this volume? All right, very good. So, as Harald said, I'll be doing sort of an introduction to Python and programming. It's intended to be a fairly general introduction for people who might not have worked with Python before. I know that a lot of you have, and I'd prefer that you see this not as a, why is Daniel talking about these things that I've already known for several years? Rather see it as a, here's an opportunity for me to help the person next to me who's perhaps doing this for the very first time. So if you feel that the things that I'm going through is too simple, too easy, as Harald said yesterday, look around and see if there's someone who might not find it as easy, and spend your time helping them. I would also like to hijack the animal groups. We'll be doing some exercises throughout this workshop where you'll be talking to other people. Of course, that's one of the main wonderful things about being at a summer school, right? So I'd like you all to sit in your animal groups. And I figure that we'll start with that before we actually start doing a presentation. So please find your fellow animals.
That's why we don't understand. Okay.
I was placed in the capybara group, and I won't be able to join you. So if you find the capybara group, you might be able to take my place there. I think they are over there.
But which group?
The capybara group. I can even give you my secret group card. It's the animal group card.
And what is the name of this animal?
The capybara. It's like a guinea pig, but really big. So those would be the friendly people who are sitting over there, if you want to join. So if you want to join, you can join.
There is a team with only 4 animals. Which team was it? Okay, we have a new member. Can you join that team? All right. Okay. If there is anybody else without a team, a person who was not here yesterday, who would like to join a team, Giovanni, do you want to join, or would you rather just be like on your own? So which was the other team with 4 members? What's your animal? Whales. Giovanni, do you see there is a whale group? Yeah, so you can join them. Whale group, can you show your identity? Okay, so Giovanni joins you. So anybody else without a group? Oh, Annemieke. I know you're a teacher, so if you want, you can be on your own. Okay, cool. So, do you have a group? You don't have a group. Okay, which group still has 4 people? You have 4? Okay, so can you join them? So everybody is in a group.
I got the question from the group at the end if we could bring down the sun things. Yeah.
I got the request to make less light,
Yes.
so I will push the button. Hopefully the right one.
All right, so it looks like everyone has found their groups. Is there anyone who is sitting by themselves and who hasn't found a group yet? All right, very good. So, in the preparatory materials for the workshops, you'll be able to find a link to this document. It's linked under workshop 1. And that is a Google document where you're going to find links to all of the notebooks that I'm going to talk about, as well as to the presentations. Let's see, I'm seeing the number going up, so I'll wait until it's a bit above 60. All right, if you're having any problems finding the link or accessing the document, please raise your hand and I'll try to help you. Okay, so it looks like people have been able to find their way in. That's very good. So, at the top here, you'll see that there's my name. Hello, my name is Daniel. Thank you for the wonderful introduction, Harald. But more importantly, you'll see 2 other names, Vesturs and Stavrola, who'll be assisting with the workshops today. Would you please stand up and wave to people so that they knew how to ask or who to ask for help? They're both very kind, I've noticed, so ask them if you get stuck. So I'm going to basically do the same thing for each of these sessions, which is that I'm going to talk for a bit, and then we're going to do something practical together in Google Colab. We'll get to the collabs in just a bit. When we open the first one, I'll talk a little bit about how it works, and I'll show you some traps that you might end up falling into as you open more and more of them. But we'll start with a very, very general topic. So Python and programming. Could be basically anything, right? And as Harald's kind of hinted at, I'll be doing this from a perspective where we're talking about Python specifically, but we're also trying to be a bit general about how we can engage with programming as humanists. My background is in literature, mainly American 1920s literature, and then kind of by accident I ended up in linguistics, which is how I ended up with programming. So you'll note that I lack computational background. And I've put this together sort of on the assumption that a lot of the people who are now engaging with programming within the digital humanities kind of do, that many of us are humanists, but I know that some of you have a more robust background in that sense than I do. So we'll start talking about programming generally, and then we'll talk a little bit about data structures, we'll talk a little bit about how to read code. And reading code is the intended end goal. That's where we should be by the time we have lunch. And I'm not talking about necessarily sitting down and reading code at a very detailed level, at a very technical level, but rather reading it for understanding, the same way we might read a book or a short story. Looking at a script and trying to figure out what is actually happening here. But just as a matter of my own curiosity, how many of you have worked with Python before? If you raise your hand. Okay, so that's a good number of people. Which should make this very, very interesting, because I imagine I'm going to say some things that you might disagree with. I encourage you to do so. All right, so coming from literature, coming from a background where we deal very much with close reading, it's always kind of interesting to look at what might we gain from engaging in a specific practice. For close reading, we often talk about the value of reading literature, right, as a window into the world. When it comes to programming, there are many other reasons why we should engage with it beyond just it allows us to do really cool stuff. Let's see if I can move Zoom around here. Aha. So we can look at programming as something that we engage with because it enhances our problem-solving skills. It enables us to automate repetitive tasks that might make our days less enjoyable. It's something that enables us to work with more and more data. And those of you who have already spent some time looking at digital humanities literature will probably find that that was a very big thing for a very long time, this ability to suddenly engage with more and more of whatever it is that we're interested in. Instead of looking at 20 novels, we look at a couple of thousand, right? And it's also something that plays a very important role in how a lot of the stuff that we do is disseminated through things like interactive project websites, through things like tools and software, through all of these wonderful, cool digital outputs that we see popping up. It tends to be reliant on code to some extent. Not necessarily Python, but code nonetheless. And programming is also something that we could look at as a way that encourages us to become, I kind of dislike the word logical or rational, but at least a bit more structured in how we think through our project designs. So beyond just being able to practically do things, there are benefits in engaging with programming that might benefit you in more ways than just that. Now, someone might say that a lot of this you could also gain just from doing a Sudoku with breakfast. And that is also kind of true. But there is sort of this nature of engaging with these exercises or these practices that I think is quite rewarding in and of itself. So why Python then? Since a lot of you have already sort of had some experience with Python, you might already know this, but Python is considered a friendly language. It's supposedly one of the easier languages to learn when it comes to programming. It's one of the languages that supports you quite a lot as you're working with it. It is quite clear in what is happening for a human reader. It's also something that is widely used for many different things. For digital humanities, we use it a lot for our methodologies, right? But it's also something that could be applied towards other things. And this brings with it that there is a large community that works with Python and that distributes training materials or that distributes guides on how to do different things. If you just Google a Python guide or Python insert method guide on, or look it up on YouTube, you'll see that there's a large amount of videos where someone will walk you through how to do something because there are a lot of users. And that is something that is a massive value for the programming language in itself, and especially if it's the first one that you're engaging with, because there's a lot of support to find. It's also something that easily integrates with other tools and languages, at least when you look into the described benefits of it. If you're working with a tool like Nime or like Orange, Python is often one of those things that you'll be able to modulate into it. So it's something that is likely to work with what you're already familiar with. I'm really desperately trying to make the argument as to why you should find this interesting here. But since you're all here, I think that's kind of a point that's already been sold, as they say. All right, so as I said, we'll be working in Google Colab. And Google Colab is wonderful for, at least from my perspective, one main reason, which is that we don't have to set up a Python environment on each of your computers. Having previously done summer schools where we've worked with local development environments for each student, it's something that tends to kind of eat up the full first day because there's always some issue. It's always something that goes wrong. With Colab, in theory at least, you should be able to just click the link and run it. So it's a free cloud service that we can use to work in Python. Wonderful so far. It's based on something called Jupyter Notebooks, which you can also find in other variants that might suit your needs better later on. Basically, it allows us to work with the code in our web browser. There shouldn't be any setup required, and it uses Google Drive to actually store code and the materials that you're using. Another wonderful benefit, especially if you're working in a group with your research, is that you can share it easily via link, the way that we've shared the notebooks here. And unlike sending scripts back and forth, sharing a Google Colab should enable the other person to simply click on it and then run it without having to necessarily do a lot of setup on their end to get it to work. There are, of course, quite a lot of drawbacks to this as well. Nothing is just wonderful. When it comes to Google Colab, we are essentially running our scripts and our data on Google Drive, meaning that you probably don't want to work on something that you wouldn't leave around on Google Drive in terms of your research data. If you're working with sensitive interview materials, if you're working on materials where it's been a part of the research design that these should be kept locally, this should be used in a somewhat secure environment, Google Colab is probably not the best way to go about it. So depending on what you're working on, do consider what you're uploading. If you wouldn't send it over Gmail, then perhaps Google Colab isn't the way to go. There are also resource limitations to keep in mind because Google Colab is a service at the end of the day. It is something that you can buy access to. There are subscriptions, so on and so forth. So there are resource limitations in the free tier, which is what I'd imagine all of us are using. There are also kind of built-in issues with running it on the browser as a notebook because there are dependencies that aren't on the virtual machine that it's running on. So cloud services aren't anything that happens magically, right? There is a computer somewhere, or a virtual computer in most cases, that runs this. So when we actually have to make sure that everything is in order and that everything is where it should be, Google Colab can make that a bit trickier than it would be on a local machine. And finally, which I hope won't be an issue, you need to have an internet connection in order to use it. So if you're looking for something that you can use for fieldwork in locations where you might not have access to the internet, Google Colab might also be kind of an issue. Finally, there's something called session limits, right? And that is the number of Colabs that you can run at the same time. It's rarely become an issue for my use cases, but during this week, since you'll be looking at a lot of notebooks, we're going to look at that as well, so that if you get stuck on the limit there, you'll be able to remove some of the previous sessions. All right, so those were some just general things about what we're going to talk about today. We'll return to Python more explicitly here. And as I've already mentioned, my background is in linguistics, and that has kind of tainted my understanding of the world, where everything is language and linguistics, right? I'm sure it's the same for you with your fields. But I am fairly confident in saying that Python is a language at the end of the day. It's somewhat similar to English. It's a system that has its own grammar, what we call the syntax. It is something that is mainly influenced by the two audiences in mind at its creation. Those two audiences are kind of what makes programming languages interesting, because they are programmers and computers, right? When we're looking at a programming language, we want a human understanding of it so that humans can create it, and we need a computational understanding of it so that computers can actually run it. This is important to keep in mind, because there is some weird stuff from a human language perspective that happens in programming languages because, well, one of the audiences isn't really human in that sense. We also have to keep in mind that it's a constructed language, meaning that someone has sat down and sort of written up the rules for it. So how does it work then? If this is your sort of first introduction to code, well, code runs from the top to the bottom. It sounds super simple when you say it, but when it comes to actually figuring out the order of how we put things in our scripts, it can be a fair bit tricky, because it's a truth with some modifications to it. This has to do with the later parts often being dependent on the earlier parts. What we end up starting out doing in our scripts is often setting up what's going to happen later on, right? And that can be a matter of defining things, but it can also be a matter of just setting up our resources. Another issue is that parts of this language, part of the sort of construction of the language, are very strict. They're used for one thing only. They can't, or well, they shouldn't really be changed. And then there are other parts of it where we can do whatever we want. And figuring out which is which, at least for me, was very tricky in the beginning. And that's also what makes reading code challenging, because parts of it are what they always are. If you find that in any other script, it'll mean the same thing, whereas other parts are user-defined, meaning that you are kind of at the mercy of whoever has written the code to provide you with a definition of what does this actually mean, what's actually included here, what is actually happening. And the matter of documentation, commenting, and actually writing up the material needed for someone else to understand the code is also something we're going to touch on today, because it is important, and it's also kind of a part where you'll sometimes find code that's kind of a bit too relaxed, especially for people like me who come from a non-technical background. Code documentation is super important because it often makes the difference between whether I can understand what's happening or not. So I like to think about code as being partially made up of magic words. And I don't know, how many of you read fantasy novels? Okay, a few at least. So when I say magic words, I mean, okay, here is a word with an imbued sort of function to it. This word is magical because this word in its explicit formulation does this exact thing and this thing only, you know? So it's sort of like a spell. Other words are just regular words. They function the way that human language always does, which is that we kind of make it up as we go oftentimes. Understanding that separation is kind of key to being able to read and write code, or at least understanding it. At least it was for me. So there's a lot that we're going to cover in this first segment, and a lot of it is kind of boring. Whenever we start learning a new language, we kind of have to start learning the components of the language, right? You might remember this way back when in like primary or secondary school, where you were just given long lists of glossaries for whatever language you were studying. Just learning the words, because you have to know the components in order to put them together so that you can communicate. And programming, for better or worse, is kind of the same thing. We have to learn the basic building blocks, and we have to learn some of the words. Otherwise, it's difficult to put things together, it's difficult to read. So we're going to talk about variables, data types, loops, and functions. We're going to talk about these several times. I am a firm believer in that repetition is, you know, how we learn things. So we'll do everything twice. Some things we'll do 4 times as well. If you want us to do it a 5th time, just tell me. I'm happy to do the same thing over and over and over. So these terms are, if this is your first time encountering them, kind of opaque. Understanding exactly what they mean, and more importantly, what they do, it's not all that clear. At least it wasn't to me. Some of you might be getting this at first glance, and that's great. The reason why we're covering it, as I said, is because reading relies on familiarity. You need to know a little bit about what it is that you are reading in order to be able to parse it for some meaning. And that's kind of what we're aiming to do. We want to read the components of the code to understand what they do. And the specific wording here matters less. What we're after is kind of the narrative, the story, what's happening in a code script. Do any of you have these strong memories of the first time you read a short story in a second language way back in school, right? Maybe you didn't understand every word, but you started understanding what's happening to the character. I don't understand the specific description of what the weather was like that day, but I know that they went to the market. That sort of thing. And that's sort of where I want us to end up today. I want us to know what's happening. We might not get all of the, you know, environmental descriptions, all of the beautiful dialogue, but at least we know where they are and what's happening. So we're going to focus on just reading components. We're going to look to understand the blocks of the narrative. What is happening to who and when? A starting point for us to be able to do this is understanding variables. Now, I've heard variables explained in many interesting ways. My favorite thing is that a variable is like the lunchbox in your fridge, where you can put anything in it, and then that is your lunchbox. And you bring your lunchbox to work every day. The content depends on whatever's left over, right? Whatever you want it to be in our case. Because variables become stand-ins for anything. And that is kind of difficult, because when you have something defined as can be anything, essentially, it's kind of difficult to wrap your head around. But grammar-wise or syntax-wise, it's quite simple. We define it with an equal sign. So we can say that a variable is 5 or a variable is John. And once we've done that, that is what variable is. It becomes a placeholder. So in the first notebook we're going to look at, we have a variable called x, and it is this sentence. I am a string of characters. That is what x now means. All of the things that this is now what x is. It sounds kind of silly when I'm explaining it like this, but it becomes really confusing really quickly, I promise. Because anything that we change with x kind of alters it, and it has become somewhat opaque at that point. So following the narrative of what happens to x becomes kind of tricky. But we start out with variables. These are our things. These are whatever the story is about a lot of the time. Now, there are many different things that exist in the ecosystem of a script. We can talk briefly about data types because that's often kind of central to our story. It is what's involved in the events that happen. It is the thing that we are working on doing something to a lot of the time. A basic one would be strings. You remember that X was the sentence, I am a sequence of strings, was it perhaps? Let's go back, have a look. I am a string of characters even. And strings are text, for lack of a better or more, what do you call it, more elaborate explanation. This also becomes tricky when we're first starting to learn to read code because all of it is text. That's kind of what we're looking at, right? But some of it is text in the story and some of it is just a description of what's happening, describing the events, giving us all of the context to it. Strings are actual text, for lack of a better explanation. More specifically, they are text characters that are handled as such. We also have numbers, and we can talk about text, we can talk about numbers. Numbers in terms of Python or in terms of this sort of programming, there are two categories to it. There are integers, there are whole numbers, and there are floats with a decimal or point. So 5 would be a whole number, it's an integer. Float would be a decimal, it's 5.4. This distinction, when you're first engaging with programming, seems kind of silly. I mean, they're both numbers. But one of the quirks of talking to a computer is that they're hyper-specific, right? Everything should be very neatly defined, and it should be understood quite explicitly. And we'll start talking a little bit about why that matters in just a moment. So, since it's so central, we often end up wanting to check what kind of type something is. Is it a string? Is it an integer? And we do that by using type. Type is another wonderful quirk that we'll also return to later on. It's something we'd refer to as a function, essentially. So we have a magic word, which is type, and magic words can be followed by a parenthesis, and in that parenthesis, we'll find whatever we're applying it to. In this case, we're checking the type of our variable called variable, which is very bad practice. You shouldn't call your variables variables. So, we're applying the magic word type to variable, which is our container that we've put something in. In the notebook that we're going to look at, we have two variables, x and y. One of them is a whole number, so it's an integer. The other one is a decimal number, so it's a float. And type will tell us that this is the case. We have the magic word type within another magic word, print. Print basically applies print to whatever is in the parentheses. What print actually does is that it prints it for you so that you can see it. It's not super exciting, but it's a lot of fun. You can do a lot of weird things with print statements. So, why is this important? Well, certain actions will expect a specific type to be fed into them, and some will do different things depending on the type that you're giving to it. So, if you use something like the addition sign, and you use it on integers, you get just addition, right? If you use it on string, you'll get concatenation, so adding it together. They're both the same thing. You're using the same buttons, but depending on what you're doing it to, you get a different outcome. And therefore it is important. It's also important because in order to understand what's happening when we're reading the code, we kind of need to get an idea of what is being done to what, right? All right. Another thing that's going to be recurring is the concept of a list. So a list is a list of items. They're within square brackets, and they're separated by a comma. Here we have an example that is a list of strings, and the strings in this case are apple, banana, pear, and tomato. I've stored all of them in a variable called fruits in this example. So fruits is now a list. Within this list, there are a bunch of strings, that is to say text, and they are in this specific structure. You can put most things in a list, and it's something that is kind of a reoccurring thing. It's kind of the bread and butter of a lot of the stuff that we have scripts do. Here I've created a list that I've called list, which is also a very, very bad practice, because list is a magical word, and now I've redefined it to just be a string of, or just be a list of strings. And we have to be somewhat aware of these things. Google Colab should be very angry with you and give you a warning if you try to do this. But I wanted to point it out because it's yet another reason as to why we need to be a bit aware of the glossary of the language that we're engaging with, the words that are magic in the context of whatever programming language we're working in. Because computers will let you do really, really dumb things. A lot of the time they won't stop you. You're allowed to break your own creations at any given time. And frankly, sometimes you should, because it's fun and it's something that you learn a lot from doing. So, why are lists so important then? Well, you can do a lot of things with lists. So, you end up with just fruits. It's a list that contains fruits, right? Well, if you want to have a specific fruit, you can call that by its position in the list. Note here that lists start at 0. So 0 is the first item. Second item is 1. Also kind of a tricky thing when you first encounter it and when you start reading code. But the first thing here, apple, it's fruits 0. The list starts at 0. So fruits 1 will, on the other hand, return the second item, so banana. We can also add things to our list. We can add, for instance, orange here. So we just use fruits.append. Append would be a magic word. It's followed by a parenthesis, which gives us what we're sort of applying it to. We can also remove things, or we can look at the length of the list. So, for instance, we use len, we give it our own list, and it'll give us how many things are in this list. Once again, when we're looking at a list of fruits, it doesn't seem all that useful or that cool, but as soon as you start producing any type of output, any type of data, it could be words in order of frequency for text, right? Being able to pick the most frequent one is just a matter of picking whatever's first in that sorted list, or in that ordered list. So these things become really, really important. And they also become a matter of being able to follow your list throughout the script and understanding what's now in it, what's been added. Another fun thing that you'll encounter over and over again is a loop, which does things over and over again. Loops can be formulated in different ways, but we're looking at the simple one here. And basically what a loop does is that it does something to things in a sequence, right? Here, we're sticking with our list of fruits, and we're saying for each item in fruits, print the fruit. I've used fruit here because it's somewhat intuitive. So we have a list called fruits. In my loop, I'm saying that for each fruit in that list, do this thing. We could exchange fruit here for anything, as long as whatever's in print matches. You can use a placeholder variable here saying for x in fruits, print x. But here, it becomes a bit opaque, right? Because we've hidden what's happened. And a good thing to keep in mind when you're writing is that your writing should be easy to read. We rarely consider that an important insight when we're talking about writing text, but whenever we write code, we tend to forget it very quickly. And we start doing very complicated things, and we start expressing them in a complicated way. and then we take a 6-month break from the project, we come back, and we now have to understand what we've actually done. It still happens to me all the time. So, try to keep some clarity in what you're doing. Same is true here if we have a sentence, which is an example from the notebook that we're going to look at in just a few minutes. We say, okay, for each word in the sentence, print the word. It's fairly clear what we're doing. So, on the topic of redoing a thing over and over again, we should talk a little bit about functions. Now, functions are wonderful because they allow you to be super duper lazy, which is the kind of key goal of learning programming, I'd say. What we do is, in this case, we're defining a function. I'm calling it my function. And we're basically creating a magic word at this point. So def being defined, my function, which is the magic word that we've now made up, and then followed by a parenthesis where we're giving it a placeholder. And the way that this works is we're defining a magic word that's going to do something to something else. That's something else. Here I'm using list, which you shouldn't do because it's already a magic word. And I'm using it as placeholder to say that for any item in this list, print that item. It's the same loop that we've seen before, but here it's put in a function. Why might we want to do that? Well, the next time we want to do this thing where we print whatever is in our list, we can just say my underscore function and then give it the list that we want to apply it to. For something as simple as just this loop, it might seem a bit unnecessary, but as you start writing more complicated things, it saves a lot of time. And more importantly, it keeps the code clear so that it's easy to understand. Here is a defined thing that I'm now doing to another thing. I found functions very, very tricky when I started programming, but I'm pointing them out here because they become central to reading a lot of code, understanding, okay, what is applied here now with this one new word? It's not a magic word that I recognize from my big glossary of Python terms. It must come from somewhere. And that somewhere will oftentimes be a function defined earlier on in the script. All right. Another thing that I should probably have mentioned much earlier. So in the document where you find the links to the PowerPoints and the notebooks, at the very end of that document, you should be able to add questions if you want to as well. Everyone should have the ability to edit that document. Please don't do anything too weird with it. But if you have any questions that pop up, you don't want to ask them, you can just write them in the document, and I'll look at them in the break. All right, so here we have an example from the notebook where we have defined a function that's called addition with 3. And we're using x as the placeholder. And it does what it says. It adds with 3. And then prints the results. Okay, so final note then. Libraries, you'll be seeing a lot of them during the week. A library could be understood as just importing a bunch of new magic words into your script. That's an oversimplification, as is all of what I've already said. But the way that we do it is that we install a resource that contains a lot of useful stuff, and we then apply it in our script. And it's important to be aware of because it also becomes a source of the new language in the script that we're reading. If we're starting to see unfamiliar things, they might also come from one of these imports. Luckily, this should be explicitly mentioned in the script as well, because they have to be explicitly imported, right? Nothing just appears, because the computer needs to be specifically told to fetch it, to create it, to do it. We're also going to talk a bit about data frames. We'll talk more about that in the next session, but they're often connected to this library called pandas. And I'm bringing it out as an example because it's something that you're going to see in a lot of examples. It's something that you're going to find in a lot of the scripts you might see online. And it allows us to interact with something like a spreadsheet, like table, essentially. That's what a data frame is. And pandas comes with the ability to create these and to interact with them in a bunch of different ways. And that tends to kind of be at the core of what we're trying to do, because whenever we want to bring something into our script, whenever we want to put something out of our script, whenever something enters or exits the story, if you will, we'll need to do that in some sort of structured manner. And just importing something like pandas creates a massive new amount of magic words that we need to take, that we need to be somewhat aware of. So all of the things we see here are things that sort of can appear with pandas, new things that you can do, new magic words that you kind of have to learn and understand. We're not going to dwell on these for very long. It's just sort of kind of showcasing that point. All right, so finally, after a very long talking session from me, sorry, you'll get to do something fun for yourselves. If I can figure out how to go back here. Haha. So what we're going to do now is this first Colab notebook. Before we move on to that, are there any comments that you want to raise at this point? Any explicit questions? Any definitions of mine that were far too wrong for you to be able to live with it? Please go ahead.
I actually understood it, but maybe it's worth a bit spending time on equal sign and double equal sign. What's the difference? Because it might be confusing for people who know some math.
Okay, that's a very interesting point. Now, let's see if I'm able to go back here. Okay, so because single equal signs are used in the syntax of Python, right? When we define a variable, the double equal signs become used in the actual is the same as. Does that make sense? Okay, so let's say that I have an integer and that integer is 5. I'm defining x as 5. So I'm using just the equal sign to say x is 5. Then in the next section, I want to create a loop and say, okay, print only if this equals 5. In the second equals, I would use two equal signs. Sorry, lots of equal in the same sentence. But essentially that becomes the checking point then, actually meaning is equal to. And there's a couple of different combinations there as well, because here you have equal equal, so equal to. You could also have equal or greater than, that you would also just stack on each other. So you'll find a couple of different variations on these dual checkers, if you will. Did this make it clearer or just more confusing? We'll look at some examples as well. Thank you for the input, Haralds. Let's see. Okay, so this Colab notebook is the same thing we just talked about, but with code examples. It's not very exciting, but as I said, I truly do believe in repetition. So, this is also kind of an introduction to Google Colab. So Google Colab has two components, text cells and code cells. Text cells are just the text that I've put into it. The code cells are actual code that you can run. Before you start doing that though, I would strongly suggest that you start by creating a copy on your own drive so that you can make changes and save them, make any alterations, that sort of thing. The way that you do that is that you go to File and you click Save a Copy in Drive. So this will give you your own personal copy of the file, the same as it would for something like Google Docs, right? Meaning that you're free to do whatever you like with it. Is there anyone who has any issues accessing the notebook or anything like that? All right. So, you can ignore this first text mass, and indeed most of them. I've put quite a lot of text in here because I reuse this Colab as an intro quite a lot. If we want to run a code cell, we simply click the play button. All right, so this notebook was not authored by Google, it's authored by some random Swedish person. You might want to consider trusting it. So, what we've done here is that we've run just print, and we're running print on the string hello world, which is traditional. You'll see that what happens is that it prints hello world. It does what we asked it to do. All good so far? Okay, so want to do something a bit more interesting, we can add two numbers together, two integers. So what happens when we press this? Oh, I misclicked. There we are. So it prints 8. And it's also an important thing to note is that it prints what happens in the parentheses. It doesn't print 4 plus 4. It prints what happens when we do 4 plus 4. All right, I'm now going to show you a great matter of annoyance. Let's see, if I go here, maybe? If I were to put these around it, it becomes something else, right? It becomes a string. And when I now run it, it just prints the string. So, kind of showcases that with different things happen. When this becomes infuriating is that you have a variable that you're printing. You're no longer seeing exactly what's happening in print. And that variable has somehow ended up being a type that you didn't kind of anticipate it being. And everything goes wrong. Instead of printing your very cool results of adding 4 to 4, you just get random output. Or in this case, you get 4 plus 4, whatever the result of the action with that variable is. And this is why things like keeping in mind the type of a variable become so very important. So here we now have said variable. We have a variable called x, we're defining it as 4. And you'll notice that nothing really happens here, because all that we're doing is we're defining the variable. There is no output, nothing gets printed, because we haven't asked for it to be printed, right? We're just defining a variable. So now magically in the background of this, x now means 4, meaning that when we print x plus 4, no, x plus 2, we get 6, because x is now 4. So it's the same thing being held sort of in that container of x. We can do the same thing with the previously shown string of characters. So we can say that x is now a string of characters, and we can then print the type, and we'll see that it is str or string. Ta-da! It doesn't seem very cool, but it's important, I promise. Here we have our other example where we have one float, we have one integer, and we can check the type here as well. So y is the float, x would be the integer. I would like you all to replace the y with the x so that we apply type to the other one, just so that you can try to make a change in a cell. If you need any help, just raise your hand.
Should I put X here?
No, there. And then if you press run there, the play button, you'll see it changes. So if you change that to y, you're then applying it to 2.5, it becomes a float. So you've already changed it, you can press there, and then it will show float. Yeah. So it's just sort of how it goes together, right? All right. So I realized I'm a bit behind schedule, so we'll carry on. The point I'm trying to make here is sort of, I think, the strength of learning to code early on, that we now have something, we just change whatever's in the container, we just change the container, we do the same thing with it. As a lazy person, having a computer do these things is so nice. But it's also important to see here the structure of how it goes together. We have print, which means it's going to be printed. Within print, we have type. And type is what's going to check the type of the variable. So we have print being applied to the result of type. And type is applied to the variable. By changing the variable, we change what this process is applied to. So we can then move on to looking at lists. As you can see here, I've stopped using list as the variable that I'm storing my list in. We're instead using my underscore list. It's a small change, but it's an important one, because we're no longer using a magic word as the name of our variable. In our list, we have a list of strings. So a list of characters. If we apply print here, it just prints the entire thing. If we apply print to my list, square bracket 0, we print whatever is in position 0 of the list. And as you all remember, lists start at 0. So we print the first thing. Now, there is a lot of other stuff you can do with lists. You can do things like printing a slice of it, if you will, or printing just a couple of these items in these positions. If you want to print, you know, the first 5, or the last 5, the middle 5, whatever. All of these things are sort of available in how we work with lists, which is why they're so very useful. Moving on to talking a little bit about texts, and as I think I've already mentioned, I have a bias here towards text. It has to do with my background. My world is text. I know that quite a few of you are working with other things like images, things like audio recordings, things like pieces of art. But text is a practical way to get started when we're starting to learn about programming because it's quite explicit. It's there. So here we have a variable which is named sentence. We're defining sentence as the blizzard which has held New York and the surrounding country in its grip for the past 48 hours continues without abatement. It doesn't much matter. We're defining it as a string, right? That is what this is, this sentence. And we can even make doubly sure that it's a string by printing the type. Interestingly here, we also have sentence underscore list, which is a list of the same strings, but it's in a different structure, right? It's no longer a string, it is a list. As we can see from the output. This is also where we can apply things like len to get the length of the list. So, len is also one of those interesting magic words where depending on what we feed it, it's going to provide us slightly different outputs, right? If we feed it a list, we get the number of items in the list. It's nice, intuitive. If we were to just feed it a string, what do you think it will give us then? Not a list of strings, but just the string itself. I'm not going to ask anyone to answer, we're just going to do it and we'll see what happens. So I'm now sort of re-aiming this so that it is pointing towards what we defined up here, sentence, which we know is a string, right? So it now says that instead of 22, there's 135. So quite a drastic difference. The difference being that it's now looking at number of characters, right? So we're applying it to the same text, if you will. It's the same sentence. But in one case, it is a sentence as a string. In the other case, it's been split up to a list of the words in the sentence. All good so far? All right. We haven't placed a lot of attention on it, but you've now kind of changed variables around and you've applied processes to different things all by yourselves. So, I mean, for the first hour of programming for some of you, I'd say it's going quite well. All right. Another interesting thing we can do is we can look at how we add things together. For instance, here we have sentence 1 and sentence 2. They are just two lists. It's still the same sentence. They've just been split in two. The reason why we're doing this is so that we can look at how addition works here. So we're now redefining sentence. It's important to note that since we're calling this sentence, you're saying that sentence is now going to be sentence 1 plus sentence 2, that's our two lists. The thing that was previously in sentence is going to disappear. So we're redefining it. So we are taking whatever was in the sentence lunchbox, we're throwing it out, and we're putting in our two sentence lists instead. And what we end up is having those two lists combined. The reason why I'm pointing this out is that we tend to sort of keep within the same system of variable names, right? We say, okay, this one's X, this one's Y, this one's Z. Then maybe we go get coffee and we might accidentally forget where we are. We redefine Z as something else. So explicitly using very clear variable names that are what they are helps us a lot, both in understanding our own code, but figuring out what's in those containers also helps us a lot when it comes to understanding other people's code. So, for the rest of this notebook, we go through a couple of other things you can do with sentences, how to get specific parts of a sentence, or how to call specific positions of a sentence. You've already seen it on the PowerPoint, and quite a lot of it is quite... I also really dislike using the word intuitive when it comes to the way that programming languages work, but it is kind of intuitive as far as that goes. So, in the interest of time, I think we're going to move on to a simple for loop. We start this section by creating the same sentence we did before, by adding our two lists together. And it's important to note that at this point, our sentence is in a list. We have string separated by commas. Bam, bam, bam. And what we're going to do is we're going to print each word in this list. And you'll see the exact same loop that you already saw in the PowerPoint, where we say that for each word in the sentence, print the word. When we do that, we're going to get just word by word the sentence that we're putting into it, like this. So each row here is the output of one loop, one iteration of this loop. As I said before, word here is something that I've chosen because word clearly tells you what is being iterated over, that it is the word of each word of the sentence being printed word by word. But it is a placeholder. We could exchange it for anything. Does anyone have a good word? Rainbow. Very good. So now saying for rainbow in sentence, print rainbow. The same thing happens, right? Because it's a placeholder. This is really, really good. Not because we can put something like rainbow here, because it would make it more difficult to understand what's going on, but it gives us, as authors of this script narrative, the possibility of putting something explicit there that clearly tells the reader, this thing is happening to this thing. You can put X there, you can put Y there, you can put whatever you like there, but it is an opportunity to sort of be clear about what is happening. And we can apply a loop to a part of the list if we want to. So this is where we'd say from the first to fourth positions, or third positions it would be, right? No, wait. You see, whenever we start working with lists that start at 0, I become very confused. Yeah, so the first 4 positions. So from 0 to 4, print the length of the word. And it's the same thing here, where it's a very simple loop, right? But what we're doing in the loop is different. Instead of printing the word, we're printing the length of the word. The same thing that we saw earlier. Now, we can just leave it as is and be quite happy with it. The issue is that for a lot of us, a lot of the time, whatever the program produces, we actually want to store, to do something else with, right? And a lot of time, what we'll end up doing is storing it in something like a list. And here we're doing that using that same loop. But we're starting out by defining a variable called empty list. And an empty list is just square brackets, right? It's a list with nothing in it. We're then going to say that for each word in the sentence, empty list.append, which we might remember as one of the things you could do with a list, append whatever the length is of the word. So we're doing the same thing here as we did up here. The only thing we're doing different is that we're storing it in a list. And once again, nothing happens because, well, we've just stored it in a list. We haven't actually done anything with it yet. Down here, if we press play, it's going to print the list that we've now appended all of our results to. Hopefully. Yeah, that seems to be the case. So, we've taken 2 lists of strings, we've added them together to one list, gone through that list and looked at how long would each word be. We've then stored the length of those words in a list. Which, I mean, to be fair, it's a fairly sort of boring thing to do with all the wonderful, cool things you could do with programming, but it's a good starting point to sort of understand a little bit about how loops and how lists work and why they are so useful. More importantly, it's sort of providing some of the building blocks to understanding what happens in other code. We can do the same things with numbers. So in this case, let's see. We are going to sum that same list. We're going to use sum as a variable, and then int number from the empty list, that is the length of the words. We're just going to add them together. To get 114. So what's happening here is that we're now looping through the new list that we created, the empty list, which is no longer empty. Why is this important then? Well, you remember when we applied length to the sentence as a string? It's a long time ago. The output we got there was a bit higher. And the reason for that is another one of those kind of annoying quirks, which is the white space character. So a space in a string is still a character if we're counting the length of it. In our lists, we don't have empty spaces. We just have the words and a comma. So in order to sort of understand how we arrive at our numbers, we need to know a little bit about the types, and we need to know a little bit about how these things are applied. All right. Moving on then to functions. There is an additional cell here where you can look at the average length of the word, but we're going to move on so that we can have our coffee on time. So, as we've already looked at with this example, a function is just a snippet of code that we're building to reuse, meaning that we can apply it over and over again, and we can do so quite simply. We're essentially creating our own little tool. This is extremely useful for a lot of stuff, because you can reuse the same process over and over, knowing that it's going to stay the same. You're reusing the same code. And it also keeps the length of the code down and makes it easier to read, provided that the functions are somewhat intuitively named. So here we're doing exactly what we already saw at the PowerPoints. We're defining a function that we're going to call addition with 3. We're giving it a placeholder variable that's going to be applied to called x, and we're then capping it off, moving into actually telling the computer what to do. So here we're creating a variable called y, and we're saying that y is going to be x plus 3. And then to print whatever y is. Now, nothing happens. That can be fairly alarming the first time it happens. The reason why nothing is happening is we've only defined the function here. We've only said what it's supposed to do. We haven't actually used it. In the next cell, you can see that we are using our name for it, and we're giving it an actual input, 5. And then suddenly it actually prints a result. And that's an important difference to make between where we define something and where we actually use it. Remember what we talked about very early on, that oftentimes an earlier piece of code will be set up for a later piece of code. And this is sort of one of those instances. Now that we have a function, we can put it in a loop. We can give it a list of numbers to work on. So here we have a number list. It's just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We say for each number in that list, apply our new function. And it does. It just adds 3 to everything. We can then build a new function if we want to, where we give it 2 inputs, number 1 and number 2, num1 and num2, and we say that y is whatever these two are when added together, and then print the results. The difference here is that in order for this new one to work, we need to give it 2 numbers. And that is something we've defined already when we've written the function up. So whatever we define it as needing is kind of what it's going to need to run later on. All right, so has everyone been able to get through the notebook, or have there been any issues along the way? Do you want to see what happens if we define the function as this and then we try to run it with just 1 number? All right. I might have built that up a little bit too much. There will be no cool explosions or anything like that. It's probably going to be quite underwhelming. So we start by using 7 and 3. It returns 10, so it's adding them together. If we remove 3, we're going to get one of the absolute best features of programming ever. This is an error code, and it is the computer actually telling you what you've done wrong. Here it says, okay, addition with anything is missing 1 required positional argument, num2. That means that when this function is defined, num2 is defined with it, or defined as a needed component of it, and it's missing when we're now trying to run it. The reason why this is the best thing ever is that as long as we understand what it's telling us, it's fairly easy to fix in most cases. We're talking about generalizations here. And how do we figure out what an error code means? Oftentimes we simply Google it, and it will, most of the time, tell us what the issue is and how to solve it. As you get into weirder and weirder things, this will become more and more problematic. As I said, a lot of the benefits of Python relies on there being a large community and a lot of help, a lot of documentation, a lot of materials out there. As you're doing newer and newer things, not as much has been produced yet. But for most simple things, like nothing I do has ever resulted in me with me in a position where I can't find someone else who's already encountered my error codes. I'm just not that cool. So, if you see an error code, be very, very happy. It means that you can figure out exactly what's gone wrong and you don't have to guess. If you're starting to reuse already written scripts in your own projects, you're making new changes, it's also important to see error codes as a progress sign. A new error code is just as much of a step towards functional code as would be just getting it going in the first place. We should see these as happy things. So, there's coffee at 11, right? All right. Do you send people out, or? Favorite. All right, good. Any questions? Yes, please. Yes, very good. So, let's see if we can get here. Yeah, so, square parentheses, which is what we're using here, is we're defining a list, right? So that's sort of the structure of that data. Here we're using regular parentheses, and it is one of the, let's call it inputs for this function. So when we see parentheses that are connected like this, it's often, here is where we place the target of whatever action is being done. Within these parentheses, depending on how the function works, you might also place additional information that goes into how it's going to function. So if we were to say, have a function that's called addition with 3, and it takes a number, okay, so that's the input. We might also have additional information to add in that might say, okay, define whatever the output is as an integer or a float, just to sort of specify how the event takes place. The issue is that with these, you might also see them used for different purposes. So, for the list, for instance, okay, it's how we set up the list. We have just the empty square brackets for an empty list. But we also use it when we're picking out specific components of the list, the way that we're doing here. So here we're saying, okay, I want the first, the second, the third, and the fourth. And we're giving that information in squares. And here it is instead pointing to specific positions in the list, which is what sentence is here. So those are the kind of cases we've looked at here, but there are other cases where you'll also use parentheses and square brackets sort of as characters in different functions, different utilities. So it's a good question with a long answer as well. Any other questions or comments? Oh, sorry.
Is there any automatic way how to get from sentence to sentence list?
Yes. So there is something called split that we can use that will take a sentence and split it into words. And it will split on the white spaces, so the empty spaces, which I think that's the easiest way of doing it. However, how we split a sentence into words is also something that is, there are different ways of doing it, kind of. So depending on what you want to do, you might want to pick a different route. But I'd say just split will work well. Sorry.
In this example, the word.
Yeah.
What is the meaning? It's like a variable or how it works? I can't understand because I used to work with C++. It's like for X. How it works here, I can't understand it.
All right, so I forgot to give you the microphone, sorry. The question was, how does a word work here?
Because it was not defined before.
Yeah, and that's, yeah. So since word as a variable hasn't been defined before, how does it work in the loop? And the for loop is sort of built around the idea that we're doing something to whatever is in the sentence. Yeah. So we're saying essentially for item in the sentence. So we define it here. Yeah, essentially like a variable. Yeah. So here we are saying that whatever is in this list. Yeah. We can put X, we can put whatever we want there. The only important thing to keep in mind is that whatever is here needs to match what is here, because that's sort of the connection we're creating. Which makes it really tricky, because it can be anything. It can be more or less clear. If there is anything, please come talk to me.
So coffee break for 30 minutes. People who had problems installing, registering, Giovanni is over there. But otherwise, have a rest. I guess it was intense for people who first time saw programming. And also, please write the questions in the file if you have. I know it's not easy, but don't feel lost.